Claude Code becomes far more powerful when every critical workflow step no longer depends on memory, discipline, or repeated prompting. Hooks matter because they convert developer intent into automatic execution, format after edits, validate before risky commands, notify when attention is needed, and enforce project rules at lifecycle points inside the agent loop. The strategic shift is simple. Automation moves from suggestion to infrastructure. Claude, the weak point in agentic coding, is not code generation. It is the gap between what the model can do and what the workflow must always do. Developers still repeat the same guardrails, run tests, check formatting, avoid protected files, confirm dangerous commands. Existing prompting is insufficient because instructions can be missed, diluted, or buried inside long context. A prompt is guidance, a hook is execution. Claude may understand a rule, but understanding does not guarantee the rule fires at the exact moment a tool call happens. Hooks solve the architectural mismatch by attaching deterministic actions to events such as pre-tool use, post-tool use, notification, stop, and session start. Claude Hooks create a second control plane around the agent. Claude still reasons, edits, explores, and plans, but the workflow gains fixed checkpoints that do not rely on model judgment. Before an action, a hook can block. After an action, a hook can verify. When context changes, a hook can rehydrate. The agent becomes creative inside boundaries. The operating model has three layers: an event, a matcher, and a handler. The event says when to listen. The matcher says which tool, notification, or session condition qualifies. The handler runs a shell command, HTTP endpoint, MCP tool, prompt, or agent. Claude Code passes event JSON into the handler, then receives silence, output, or a decision. Claude Hook events span the full Claude Code session, once per session, once per turn, and on every tool call inside the agentic loop. Session start prepares context, user prompt submit intercepts intent, pre-tool use guards execution, post-tool use validates results, notification restores human attention, stop turns completion into a final quality gate. Claude, a practical workflow, starts with the most repeated checks. After edit or write, post-tool use can run prettier. Before file modification, pre-tool use can block .env.get or lock file changes. When Claude needs approval, notification can alert the developer. When the turn ends, stop can require tests, summaries, or review before work is considered complete. Claude Hooks can return structured control, not just log output. Claude Code supports exit code 2 to block with a message, while JSON output can deny, approve, add context, or request permission behavior depending on the event. This makes automation explainable. The model sees why a command was blocked and can adapt without bypassing the rule. Claude, the emotional change is immediate. The developer stops hovering over the terminal like a safety inspector. Hooks turn fragile habits into enforced workflow architecture. The work still feels fast, but now speed has rails. Claude can move through a repository while formatting, validation, security boundaries, notifications, and approval steps run around it like an invisible engineering team. The future of Claude Code workflows is not bigger prompts, it is composable automation. Local hooks capture personal habits. Project hooks encode team standards. Manage settings and plugins can distribute organization-wide rules. As agents take more actions, hooks become the trust layer. Small deterministic systems surrounding large generative systems, making autonomy safer, repeatable, and production-ready. Claude